In this short video, I'm going to walk you through the process of building a Bbj database from scratch. And a Bbj database is going to be constructed of a name that we call an alias that references that database. It gives you the ability to refer to that database from SQL open operations within the language, as well as ODBC data sources and JDBC data sources. So it also consists of what's called a data dictionary that maps tables to data files in your system. And so I'm going to walk through this basic structure first, and then once you understand the basic structure and how things are put together, then we'll go step by step through creating your own database. So let's get started with that. So over here in the Enterprise Manager, we have the navigator here. Under the databases folder here, we have databases. And so databases, when we open that up, we'll see a list of the databases that we have configured. Here is that name that I mentioned. Now, one thing to keep in mind is the name is case sensitive. So anytime that you are going to refer to any of these databases, you need to make sure that you match the case. Also, you'll see a type here. The type is referring to whether it's legacy, which would be our older data dictionary format, or enhanced, which is our newer format. And so I'm going to walk you through creating an enhanced data dictionary, since anything new going forward should probably be done with that format. Over here, the dictionary location tells you the location of the data dictionary files for that particular database. And we'll talk a little bit more about that as we look at the structure. So let's take a look here at this add-on software database. This is one of the demo databases that comes with Bbj if you install the demos and the add-on software option. So when we open up the properties, you'll notice here for each database there are tabs across the bottom also. So while we have this big tab here at the top for the database as a whole, we have those individual subsections of the database configuration at the bottom. So just keep that in mind. On this first page here, the main fields that we are going to be interested in are going to be the data location and the dictionary location. Dictionary location is the location of the data dictionary files that contain all of the mappings from tables to columns and stored procedures and views and all of these different database objects. All of that information is stored in that location there. The data location is going to point to where your actual application, your company data files reside. These would be your customer file, your order file, those kinds of things. So that is the location pointed to here. And you'll see shortly why we define these locations here. Now, the SQL tab at the bottom here, this is where you're going to execute SQL statements. And so it's important that you know where that is. This is where you can test queries. You can make sure that the column definitions that you've created in your database actually map correctly to the record layouts of your data files. So it's good to test all of those things anytime that you make changes. And then you can also validate queries here very quickly. You type in your SQL here, you'll see your result here, as we'll see shortly when we do some testing with this. And then the last column that we're going to point out in this introductory video is going to be tables. And so tables is where all of your tables are. So when we look at one of these tables here, let's pull up the ADC country table. We'll see our table name, a description, and the other area of interest is going to be your data file path. Now your data file path here is going to point to the data file itself. Now you'll notice here that we have what we call a global variable, and I'm going to change this because this is what yours is going to look like. It's going to look like data. What you do here, the reason we don't put in a hard-coded path is that it's often desirable to move the location of the data dictionary. Maybe we change platforms, so we're no longer using Windows, but we've decided to put our system on Linux, and so we want to change it from a C:\/ format to a / format in the path, for example. If we had hard-coded all those paths in the data dictionary, we'd have to go through and update all of those records, and it makes it a very much a maintenance nightmare. So I highly encourage you to use these variables within the paths. And those variables can be, as I said, data would correspond to this data path here that's defined. Basically, it will replace that parentheses data section with this path right here. What you can also do is user properties, and you can define additional variables if you have need to do that for some reason, and then you can insert those values within your path data as well. But we'll keep it simple here. We'll just use data. Now, columns. On the Columns tab, this is going to show the mapping of your columns to the various portions of your records. And I want to show you this to kind of just make sure you have a clear understanding of how this is. This is an example from our Chili Company demo database here. This is one record of data. And as you can see here, it's pretty clear what the information is, but it's all one big string of characters. So we have two characters here, the CH together, Chili products, some spaces, then we have another one here with a space, and so forth. So we have our data broken down. And so what the columns do is that we're mapping each of these chunks here. So in this particular case here, if we look at the definition here for the prodcat field here, this is a Bbj String Template, which is very similar to how the data dictionary maps things. But you can see we're saying it's character to length, right? There's two characters there. The description is character 30 length. So if we go here, we can see that there are 30 characters from this point to here because it pads it with spaces at the end. And then so forth. Cost method is 5. And so you can see what we're doing is we're saying, okay, this field I want to be the first 2. This field I want to be the next 30. This field I want to be the next 5, and so forth. And so that's what we're telling the SQL engine when we're creating table definitions. So let's come back over here and look. So that's exactly what we're doing here. Now in this particular case, we're using variable length columns. So in the example I showed you a moment ago, we were using fixed length. In this case, there's variable length. So let me show you how that works here as we walk through this. So we have our column names here. When we select one, it will display the details for that column down below, where then we can make changes to it. Name, description, those are clear. Data type, you would set the data type here. Type B would be business math, character, I for integer, and so forth. So these are the different types available. Numeric and everything are in there as well. The dictionary length in this case on this field is 1. Again, in our example here, this would be your dictionary length. So on this first column here, you see this 2 here. That corresponds here. That's our dictionary length. So that's what that field corresponds to in the settings here. The length type, in our previous example, those were all fixed length. So we would set it to fixed length if we were defining those columns. But in this case, these are new line terminated fields. Something that would work more with what we call I/O lists in the language. And so when you're using I/O lists, you typically will be setting your columns to be variable length for the length type with a terminator character of 10, which is your new line character. So these are the key settings here that we'll be looking at when we're putting together our database structure. But hopefully that's very clear to you how this works. So basically, again, we're just mapping a column name, a type, and a size to a different, mapping that column to a particular portion of the record, and that's how we define our tables. Now under the Indexes tab, this is going to show an index. Now in SQL, we use the term index to define, well, to refer to indexes on tables. In Bbj or BBX in the language, when we're dealing with the files directly, with mkeyed files, for example, we typically call them keys. Key 0, key 1, and then when we want to read by a particular key from a file so that we can jump to a particular location in that file, we say key knum equals 0, key equal whatever the value is, and then it jumps us to that portion of the file. Well, in SQL, we need to be able to do that too, but we use the term index. So just keep that in mind, that terminology will be used. But as you can see here, this only has one index or key, and it corresponds over here. You can see the key number that it corresponds to in the BBX language terminology. So Down below, it will show the various segments that make up that particular index. So in this case, it's just the country ID column that is part of this index. And so we would see that here. For other indexes or that have multiple segments that made up the key in BBX terminology again, you would see multiple columns down here. And so, so that's very simple there. Those are the key things I wanted to point out with the structure of the Bbj database. So as you can see, it's a little bit different than MySQL or SQL Server would be, where you have everything's done strictly in SQL. In this case, what we're doing is we're adding SQL on top of this file system that the BBX language uses, so that you can benefit from both worlds. You can have the read record direct access through the language, but you can still access that data using SQL, which is a very popular way of reading your data. Okay, so now that we've gone through that, I think it's time we can go ahead and create our own database from scratch. So let's do that. So as we do, let's close out some of these windows here to keep things clean. And we're going to come over here. The Add button on the Databases page is going to let us create a new database. You'll see here we're going to give it a name. Let's just call it New One. The action type, we are going to say, if we were creating a database definition for an existing data dictionary that we had, then we would use an existing data dictionary. But since we're creating a brand new one, we're going to click on New Enhanced Dictionary. The key is make sure you pick Enhanced, not Legacy, because we're going to use the latest and greatest features and functionality. Our dictionary location is going to be in this particular case, in this location. And the data files in this one are going to be under OK. When I click OK, it's going to ask if I want to create that directory because it doesn't exist yet. And I'm going to say yes. And now what it did is it created a series of files at this particular location that contains all the information about our data dictionary. So when we want to move that data dictionary around, or if we want to back it up, that kind of thing, we can look here and we can, let's see, we can go over here to testdb. You can see that is the directory I created it in, the DICT directory, and then you can see all these data files here are created for me. So if I were to want to move my data dictionary somewhere else, maybe from a test system to a live system, I would just need to copy this particular folder, and then all of those files would be transferred over. So I did want to point that out. Okay, so that's our new database. And now we're ready to start building it. So when we double click on it to open it up, we can see our path and everything defined here. We're going to come over to tables. And right now there are no tables in our database, so there's nothing to show here. We're going to create a new one called order header. And we're going to map it to an existing file that we have. As you can see here, it threw in the data path for us to make that easy. The name of this particular file is called ordhed, and it's in our data path. Now the next thing you need to do is, if you're creating a brand new table from scratch, including the data file, then you would want to keep this radio button here selected. But we're creating a table definition for an existing data file, which is probably what you're going to be doing most. And so you would do that and then hit Next. Now on this page, this is a string template. Now if you're using string templates in your application, it's going to make your job much easier here, because you can just paste that string template in here and it will quickly define all of your column definitions for you. If you're using IO lists, unfortunately you will have to build your column definitions manually yourself. But in this case, I have a string template, and to save time, we're going to use that. So when I paste that in, you can see here, it has all of my columns defined. It has the custom here, the order date, and so forth, and it has the data type as well as the dictionary length for me. So it's all set up so that now when I hit Next, it's populated all of the column definitions for me very quickly, very easily, and automatically. So now all we have to do is click Next to go on. If we weren't using string templates, we would have to go in and manually, using the Add button, create each of our column definitions. And again, going back to what I pointed out in that first part of the video, you'll need to specify the data type as well as the size and so forth as you go through that. Now we hit Next and it brings us to the indexes. As you can see here, it looked at the data file, the structure of the data file, and it found all of the keys that were defined on that, and it created indexes for us in SQL. And so you can see each of these has an index defined on it, and then it tells it whether it's unique or not. And so it has all of the information for us. And so it's really that easy, if you have string templates again, to create your table definitions. But even if you don't, it's pretty quick and easy to just go in and make those individual column definitions for each table. So now once we've done that, we're ready to query it. So all we have to do is come back over here to our SQL tab, select star from, our table was named order header, and then we can see our data returned. And so now that's great. However, look over here on order date and ship date. Okay, so order date is a number. It's a Julian number. It's a number that is not particularly useful for most people when they're wanting to look at dates. And so how do we get it to display a date in in our SQL engine here? So that's where we need to come back over to our Tables tab and edit our table again. Come back over to Columns, and the order date and ship date are the ones that we need to set. Now if we select order date, we see it's set at numeric, and that's because it's storing numeric data. So that is correct. However, Bbj gives you the ability to use any number of formats for your dates. And so that's going back for legacy purposes to handle all of the different date formats that people have used over the course of the years for defining dates within their data files. So what we do is we give you the ability to say, hey, this is a column and it uses a particular date format. And so I want you to return it to me as a date, and here's the format that I want you to use to interpret that data. Because some will use, in this case, a Julian number. Others may be using something called like a 3-character packed date format that it looks like gibberish if you don't use a date format to interpret it. And so we give you that ability here. For each of the date columns, you'll want to specify the format of that date. Good thing is, too, sometimes people use multiple date formats at different points in their data file, so you can choose whatever the appropriate date format is for that particular column in your table. Once you do that, you need to make sure you save your changes. Whenever you're making changes in the data dictionary, you need to click Save. And this is an important dialog that we touch on here. It's asking you, would you like to update the table's data file to match any changes to the record size and or index definitions? What that means is that any changes that I've made to record sizes, to index definitions on the within the database definition, do I want those actually applied to the data file, to the underlying data file? Usually you're going to want to say no unless you are making very intentional changes to the structure of your data file. The reason is that if I were to change the size of some of these field definitions or the length of the record, that kind of thing, and it changed it and it rewrote the data file with those changes, your application may not work anymore with it. Usually it will, but sometimes it won't. So you want to be very careful, and especially if you're going to apply some changes to the data file, you want to make sure they're all backed up ahead of time. One thing I'll point out that's a great development process to use when you're creating a data dictionary is to do it on a different machine with a copy of your live data, but don't do it on your live system until you're ready to roll it out. What that lets you do is it lets you create the data dictionary, test it with data that looks like your real data. Once you have it in place, then you can take that data dictionary, and as I said, it's very portable. We just take that and put it onto our live system, add a database definition in the Enterprise Manager to point to it and point to our live data files, and now we have a live database ready to go. But doing our development on a different machine saves us the hassle of having to, worrying about messing up our live data. So just keep that in mind as a good way of approaching this. So I'm going to say no here. And what that means is it now has just saved all the changes to the data dictionary definition, but it didn't touch my data files. So I know my data files are still going to work perfectly fine with my application. So I've made that change. And now let's go back over to the SQL tab and let's run our query again. And now you'll notice, since I changed ship date, order date has a date in it. I didn't change the ship date, so it still shows a number. But you'll see here now it has a nice date. The format that you'll see here by default is year, month, day. But again, at the application level, the application will be responsible for formatting it. So just know that when dates are returned in SQL, it's up to the application to decide how to display it to the user. So that's not stored in the database in this format by any means. In fact, it's stored as a number. So that's how we set up a table. It really is that easy to do that. One last thing I want to point out that you'll want to make sure you do, once you've created your tables in your database, and once you're ready to start testing them, testing various queries against them, you're going to want to select all of your table definitions, and you can do that by just clicking on one and doing Control A or Command A to select all of them. Then you'll want to click on this little magnifying glass here. This starts something called Table Analysis, and what this does is under the covers, Bbj is now analyzing all of the data in my tables that I have selected, and it's coming up with some statistics that it's going to use to make optimization decisions when you execute SQL queries. So when we execute an SQL query and include multiple columns in a where clause, like let's say we say select from the customer table where the zip code is such and such and the state is such and such. Well, which one, let's say both of those were indexed, which one would be better to use for optimization? We don't know that, just unless we have analyzed the data that's in that file to make the determination as to whether a zip code index would be more useful for optimization or a state index would be more useful. So in any case, that table analysis information gets generated and helps your queries run as fast as possible. So you want to make sure you don't forget that step. And so you'll see here, last analysis, none available. I ran it. I just need to refresh my list. And now it shows it last analyzed my table at that time. So now I know that my queries are going to run as fast as possible. So that is basically all you need to do to get your database set up. As you can see, it's very easy to get it set up, but there are a few steps involved. It's a little bit different than a typical SQL database would be, mainly because the SQL engine and the SQL functionality is put on top of that legacy file system that BBX uses within the language. And so you do have to take that extra step of kind of defining each of those columns in your records as we went over before. But as you can see, it's very simple. And once you get it in place, then you don't really have to do a lot to maintain it. So that's good to know there. So if you have any questions at all, just let us know. And I hope that you have found this useful and that this will get you up and running right away. Thanks.